So are faces special? So faces are an important source of information, gives persons identity, social interactions, security and surveillance, and most especially emotion and mood. And there are areas of the brain that respond only to faces, such as the fusiform face area. So as seen here, fusiform face area. And now we're going to talk about this study by Busigny T and Rosion, wherein they showed this stimulus, so a car upright and a car inverted, and face upright and face inverted. And what's really interesting is that when the car was upright or inverted, people could really tell that this it was still a car. However, when the face was inverted, there was a people could not there was a significant decrease of correct responses, and it shows to us that faces faces have faces are very distinct to us, and we have we are hardwired to see a face in a certain way rather than for say a car, which is an object. We can distinguish it from we can tell whether it's a car or not if it's upright or inverted. But for faces, it's a whole nother story. Next study we're going to talk about is Gilad, Meng, and Sinha, wherein they saw that wherein they put a face full negative, and the recognition performance was slightly above average, but when the eyes were when the eyes were added back, when the eyes were recognizable, the correct responses shot up to 90%. And it shows us that eyes are important cue for facial recognition. This is why I made this is why I made the activity to start. I just gave you the eyes of the celebrities, and hopefully most of you didn't have that much of hard of a time. And and the reason because of that is, yeah, because of this study, it showed us that eyes are very important in recognizing faces. So a quick run through is that processing faces starts at the occipital cortex, which is here, and sends signals to the fusiform gyrus. An emotional reaction towards face, whether like for example, you love the person or you hate the person, there's emotion tied to face. It is processed in the amygdala, and the evaluation of where the person is looking is tied to superior temporal sulcus. So over here. The last thing we're going to talk about is the Thatcher effect. So the Thatcher effect was proposed by Peter Thomson in 1980, and it simply states that when an image is inverted and the orientation of mouth and eyes is opposite of that of the rest of the body, people are unable to see a difference. So here's a diagram. So this is a picture to Margaret Thatcher, upright and inverted. And if you look at this picture of her, they look very similar. However, when you invert it, when you put it in the upright position, you can see that the eyes and the mouth are inverted with respect to the rest of the face, neck, and shoulders. So what does the Thatcher effect tell us? So it tells us that our perceptions of faces not only are not only are not very individualistic, that we don't look at the nose, the mouth, the eyes, the ears individually, but we look at them holistically, and more importantly with respect to a certain position. So we expect certain things to be oriented in a certain way. So if you see the eyes are upright this way, and as you can see that since the picture is inverted, we would expect that the eyes and the mouth are in the same position as if it were upright. Everything was upright. So that is why we find it, and that's what the Thatcher effect shows us is that it's not only where it's placed, but also how it's supposed to be oriented that matters. So as you can see, the mouth and eyes are correctly oriented. But if you flip it, this is when we see. But when it's flipped, when the rest of the body is flipped, and the eyes and mouth also flip, we can see the difference in the there. We can see the difference when the face is perfectly upright. And this was this was explored further in Salta 2014, and they concluded in their words, our results demonstrate clear evidence for orientation dependent sensitivity to changes in facial expression in a key component of the neural network underlying face perception. What's interesting is when they did the study is they looked at the brain, and and it showed that the face selective superior temporal sulcus, but not the fusiform face area or the occipital face area, was working when the when this image was shown. However, the Salta's work is being criticized, and it because of the lack of evidence with the lack of evidence that uh, his assumptions show. There, there's a lack of theoretical evidence. So that's it. Thank you for listening to my objects and seeds lecture. Um, together with this lecture, I added two links to YouTube videos, which are supplementary materials and will help you understand deeper what the topic at hand. So thank you for listening. Goodbye.